And so finally we have part D. And so part D said, are the data in the table consistent with the assertion that the double prime of t of x is greater than 0 for every x, and the interval 0 is less than x, which is less than 8, which means from 0 to 8, and then explain your answer. And so what you'd do is you would just go through and use MVT, which again is the f of b minus f of a over b minus a equation, and you would just plug in different values of b and a, but since I have the cheat sheet next to me, unfortunately I'm just going to show you using that method, and it tells me what intervals to plug in. And so I'm going to do f of 5 minus f of 1 all over 5 minus 1, which gives me 70 minus 93 over 5 minus 1, which equals negative 5.75. And so then I'm also going to do the average rate of change of temperature on 5 to 6. So I want to do f of 6 minus f of 5 over 6 minus 5, which is 62 minus 70 over 6 minus 5, which gives me negative 8. And so first off, we notice we have two negatives. Oops. And so by using this MVT, we find that t prime of the first set that we use, we're going to call C1, equals negative 5.75. And so this is negative on the interval of 1, 5. And then we notice that also t prime on C2, which was our interval of 5 to 6, equals negative 8. And so this follows that t prime must decrease somewhere because it goes from being negative to even more negative. And so on that interval of C1 to C2. And so if you have those two negatives, that means that t double prime is going to be negative, and therefore it is not positive everywhere in 0 to 8. So t double prime is negative somewhere, therefore t double prime is not... How do I want to put this? Does not equal a positive for all values on the interval of 0 to 8. And so that is how you work part D, and that's a little sloppy. You'll have to forgive me.